Dynamic and rapid entrepreneurial statistical measurement and assessment using tri-squared analysis. James E. Osler II, EDD. From James Osler, given at the UNC Summit, the subject matter is the tri-squared test. I am from the School of Education at North Carolina Central University, and I'd like to share a research method designed to empower you. It's all based on the notion of
three is a magic number. Yes, it is. It's a magic number. Somewhere in the ancient mystic trinity, you get three as a magic number.
the power of 3. We see it at work all the time in nature. But what if we could find the ideal balance to apply 3 both mathematically and statistically? It requires a little bit of insight and a little bit of thought about the mathematical law of trichotomy. The mathematical law of trichotomy states that every real number is negative, 0, or positive. The law is sometimes stated as, for arbitrary real numbers a and b, exactly one of the relations a is less than b, a is equal to b, and a is greater than b holds. From Tom M. Apostle in his 1967 book on calculus. It is the mathematical law of trichotomy that is the foundation of the total transformative trichotomy squared test, or the tri-squared test. What is the tri-squared test? The total transformative tri-squared test provides a methodology for the transformation of outcomes from qualitative research into measurable quantitative values that are used to test the validity of hypotheses using units of 3. The roadmap of the tri-squared test characteristics. The primary advantages of the tri-squared test are simplicity, precision, parsimony, creativity, ownership, rapidity, validity, reliability, and utility. The foundation of the tri-squared test. The foundation of tri-square includes the mathematical research investigations of optical pioneer Ernest Abbe, who derived the distribution that would later become known as the chi-square distribution. The original research of mathematician Auguste Brevet, who pioneered the initial mathematical formula for correlation in his research on observational errors, and the in-depth research of James Edward Osler II in the arena of tri-coordinate analysis, quantifiable instructional design, and quantitative education science. Here's an example of the tri-squared test probability distribution table. This particular distribution table displays the primary alpha levels associated with the critical values for hypothesis testing using tri-squared. Uniquely, error values and alpha levels are directly associated in tri-squared depending on the size of the actual N, or the number of observations or participants that are participating in the study. The tri-squared test is limited by the mathematical law of trichotomy, which provides the foundation of the tri-squared research methodology. As a statistically fixed test that analyzes trichotomous categorical and outcome variables, and the tri-squared test calculation seen here, tri-squared is equal to the total sum of the collected tri-x coordinates minus the tri-y coordinates squared as a ratio of the tri-y coordinates, with a fixed degrees of freedom that is always 4. All of this together is designed statistically to transform trichotomous qualitative data into trichotomous qualitative data. How does the tri-squared test allow me, as a researcher, to create my own instrumentation? The creation, evaluation, and assessment of quote-unquote III or what we call in the tri-squared test, inventive investigative instruments, is a part of the tri-squared test. The creation of these instruments allows the researcher to build specific assessments that are designed to explore a variety of areas. The basic construction methodology or model of the creation of these triple I's or inventive investigative instruments is as follows. Here's a sample of an inventive investigative instrument which would have your name, asset security in the form of copyright and or trademarks or Creative Commons, and then listing the items where A, B, and C are a breakdown from the research questions A sub 1, A sub 2, A sub 3, which are recognized as the trichotomous input variables, and then you have the trichotomous outcome variables in three areas, which would be B sub 1, B sub 2, B sub 3. And this is repeated down again for the second research question in D, E, and F, and then the third in G through I. Note that the following standard 3x3 tri-squared table is used for reporting qualitative results from the researcher's tri-squared inventive investigative instrument. And so you see in this row and column fashion, very similar to chi-square, you would see the outcomes that are put in that you then use the calculation to determine the outcomes quantitatively from the qualitative data drawn from the researcher's inventive investigative instrument. In this instance, A sub 1 through 3 are now called trichotomous categorical variables, and B sub 1 through 3 are our trichotomous outcome variables. The tri-squared test alpha levels and critical values are on a table, once again, that are broken down by the number of participants or the outcomes that are in the center of this particular table, and then the probability needed to reject the null hypothesis. So it all aligns. Arbitrarily selecting a null hypothesis is not alpha level for the null hypothesis is not needed because that is factored into the exact number as small, medium, or large unit intervals in multiples of 3. Can tri-squared be used with other data? The answer is yes. The operational parameters of the tri-squared test allow it to be used with a variety of data and research experiments. Once the researcher reduces the data and or results into statistical trichotomous categorical and outcome variables, thereby following the mathematical law of trichotomy, which is the foundation of the tri-squared research methodology at any stage of the research design. There are, in fact, several different areas in which tri-squared can be used that are now referred to collectively as triostatistics, in which the researcher can use the base tri-squared methodology to analyze a variety of other data. The mathematical law of trichotomy is the foundation of the tri-squared test. And let's review that now. The tri-squared test provides the following: parsimony or simplification, precision or accuracy, and power or ownership. So we may summarize all of this by saying that the tri-squared test is an innovative research methodology that incorporates, infuses, and integrates the best of qualitative and quantitative data analysis. It combines, compares, and analyzes data to determine the validity of a research hypothesis through dynamic and investigative strategy. This strategy can be used as a practical model for in-depth research investigations and inquiry. Here are some of our online resources for more information. The particular videos shown as 1 and 2 will further explain tri-square and show the exact methodology for analyzing and transforming qualitative data into quantitative data. A number of supportive research papers are available as well. The tri-squared test and its associated research has won the following. The first, North Carolina Central University Chancellor's Award for Innovation during the 2014-15 academic year. So where do you want to go from here? The answer is the sky's the limit. Thank you for watching this presentation on the tri-squared test.